So the next is work done by conservative force. See, in the previous lectures we are dealing with the conservation theorems. So before the conservation theorems, we must know what are conservative forces. During the conservation theorems, we said that anything which depends only on the initial and the final points is a conservation theory, right? So from that only, if I say what is a conservative force, so any force which will do some work which will eventually depend only on the initial and the final point will be known as a conservative force. So what I'll do is, conservative force के लिए I'll consider a cycle along which work is being done. There is some amount of work done W, and what I'll do is I'll divide this cycle into 2 points A and B, which are exactly the opposite end. So what I'll do is dW is given as force into ds vector, where F here is my conservative force. So the total work done by this force along the complete cycle, I'll say complete cycle, will be given as W is equals to cyclic integration of dW, and the cyclic integration, I can divide this whole cycle into 2 parts, A to B and B to A. So it will be A to B F dot ds vector plus cyclic integration of B to A F dot ds vector. Now one point is, when I was considering the complete cycle, I was writing the cyclic integration. But since I am breaking it into 2 halves, this will no more be a cyclic integration, but it will be a normal integration. Now this is a conservative force, so that means it will only depend upon the initial and the final point. There is no point of what is the part taken. So if you see A to B, initial point, final point. In this case, initial and final, it is exactly the same. There is no difference whether the system is going from here or here. So this integration will turn out to be exact opposite of this one, just the negative sign. So I'll write the total work done will be A to B F dot ds vector minus A to B F dot ds vector, and this will cancel out, and my total work done will be 0. This is a major result. Now the second definition of conservative force will be, if the amount of work done by a force for a cycle turns out to be 0, that force will be known as my conservative force, right? Now next is work done by work done by non-conservative force. So just like this one, if I consider a non-conservative force, that means it will depend upon the part taken. So this will not be the exact opposite of it. As a result, following the same procedure, I will not get work done is equals to 0. So if the amount of work done during a cycle by a force is non-zero, we call that force as non-conservative force. Is it clear? Very simple. ये conservative है, जो इसके बात नहीं मानेगी वो non-conservative है. Next is, just like the kinetic energy, now we will find the work done in terms of potential energy. Okay. Now, potential energy is again a form of energy. So my you can say work done or the potential energy will also be given by F dot ds vector. That remains the same. The first thing, the difference is now potential energy की जो definition होती है, it states that it is the amount of work done from bringing the point which is under observation from point 1 to point 2. So यहाँ पे इंटीग्रेशन होगी 2 to 1. अगर मैं इसको सीधा करूँ 1 to 2 जो भी हम जनरली करते हैं, it will be 1 to 2 negative of F dot ds, because potential energy is again a kind of conservative energy and conservative force. So first result is this. Now we say potential energy, since it is dependent on the spatial parameters, so I can say potential energy is a function of x, y and z, which in terms of partial differentiation, if I say, I can say the expression for V will be del V by del x into dx plus del V by del y into dy plus del V by del z into dz, right? And this will be, since it is addition but we are taking a very small change, I'll write d over here. Now if I break this expression, जो कि एक डॉट प्रोडक्ट हमें साफ साफ दिख रहा है कि x का कंपोनेंट x से, y का y से, z का z से, so if I break it separately, तो I'll get del v by del x plus I cap del v by del y j cap plus del v by del z k cap dot product dx I cap plus dy j cap plus dz k cap. This is very clearly we can see. Now v being a constant function of all these things, we can take v outside. If I take v outside, this function, it is the del operator. We all know that. So I can write it as del operator v. And what is this operator? This is nothing but the displacement vector ds vector. We can all see that. Now ये आ गया मेरा dv का एक्सप्रेशन. अगर मुझे पूरा v का निकालना है तो इसको इंटीग्रेट करना पड़ेगा from the point 1 to 2 and this will be v. v का एक्सप्रेशन we have already found here in terms of force and displacement. तो अगर मैं इसके आगे इसको सब्स्टिट्यूट करूंगी, what will I get? Taking the 1 to 2 part, I will get minus 1 to 2 f dot ds vector is equals to 1 to 2 del operator on v dot ds vector. From here we can very well compare and put the value. Since ds is here integration gets cancelled, or you can say we can leave it. So what I will get is, I will get this f force vector will come out to be negative of del operator on v. That means force is negative gradient of potential. So हमने पोटेंशियल एनर्जी का फॉर्मूला डायरेक्ट निकाला जो हमारा वर्क का होता है. उसके बाद हमने पोटेंशियल को इन टर्म्स ऑफ ग्रेडियंट में निकाला. ग्रेडियंट को जब हमने कंपेयर किया तो मेरा जो फोर्स निकलता है, तो कोई पोटेंशियल एनर्जी को जब हम स्टडी करेंगे तो पोटेंशियल एनर्जी कैन बी रिटन एज द नेगेटिव ग्रेडियंट ऑफ पोटेंशियल विल कम आउट टू बी माय force which will be in conservative nature because it is only depending on the initial and the final positions. So this is my force. Why is it negative? Because it means that force will always be in the decreasing potential. Let me write it here. This means force is always in a direction of decreasing potential. It means if I have a force and a particle under consideration, under observation, so under the influence of that force only, that particle will always move from the higher potential to lower potential, just like the electron moves from a higher potential to lower potential. Is it clear? So this was the meaning of this. I hope this is clear to you so that we can move forward. So now next will be 11th, which will be work done in terms of potential energy. Potential energy we have derived now. What is its value? What is its significance? So I'll just write it directly. Just like the kinetic energy, उसमें भी जो initial था उसमें भी वही part है, वही conservative force है. The only difference will be 1 and 2. The work done in terms of kinetic energy was T2 minus T1. But here it is the negative gradient of the potential. So we'll get work done will be in going from point 1 to 2, the work done will be V1 minus V2 because the force here was a negative gradient and the work done is given by F dot ds. Now the next is work done by a central force. Now what is a central force? Central force is introduced whenever we are talking about the rotational energy or rotational system of particles. So in that case, whenever I am talking about the central force, that means that force is always directed either away from the radial vector or towards the radial vector. It will always align with the radial vector. So I'll write the central force is a force which is always directed either towards the रेडियल वेक्टर भी बोल सकते हैं या सेंटर ऑफ द मोशन भी बोल सकते हैं, क्योंकि सिंस इट इज अ रोटेशनल मोशन तो जो सेंटर पॉइंट होता है वही उसका रेडियल वेक्टर होता है, या फिर टुवर्ड्स द फिक्स्ड पॉइंट भी बोल सकते हैं अबाउट विच द बॉडी इज रोटेटिंग. सो फ्रॉम हियर आई विल राइट आइदर टुवर्ड्स द फिक्स्ड पॉइंट और अवे फ्रॉम इट. तो जो फोर्स की नेचर होगी यहाँ पे, फोर्स विल बी अ फंक्शन ऑफ आर वेक्टर डॉट आर कैप. इट विल बी अ फंक्शन ऑफ रेडियल वेक्टर, ऑल्सो इट विल बी इन द डायरेक्शन ऑफ रेडियल वेक्टर. तो आर कैप को हम क्या लिख सकते हैं? आर कैप को वी कैन ऑल्सो राइट एफ इज इक्वल्स टू एफ वेक्टर डॉट r vector over magnitude of r vector, because r cap can be written as r vector over magnitude of r vector. So this will be my radial or central force. Similarly, work done will be again F vector dot ds vector, and corresponding result we'll get, right? One thing I would like to recall from the previous lecture was, it will be the 13th one, that is conservation of momenta. Why momenta? Because here I'll be comparing two momentums. So first one is linear and angular, because they go hand in hand. If you know one technique, you already know the second technique. So my P vector over here is M into V vector. L vector is given as R vector cross P vector. In the linear motion, I know force vector is given as dP vector divided by dt. Similarly, here my torque will be given as dl vector over dt. Now, if I say there is no external force acting on it, which is the primary condition for conservation, so I'll get, if force is equals to 0, that means my P is a constant and it is the conservation of linear momentum. In case of angular, if I say torque is 0, so I'll get dl by dt is equals to 0, and similarly I get L is a constant quantity, and with that I get the conservation of angular momentum.